All right, let's vocabulary here today to kick it off. Now, so much vocabulary, but you're going to know most of this. So, a variable. We all know what a variable is. A letter that can represent any number from a given set of numbers. So we all know a variable is a letter that represents a number. Okay, we know that. Algebraic expression. A combination of variables. I hope I have a long enough link here. Write small. And mathematical operations. Now, when we're talking, of course, mathematical operations, addition, subtraction, multiplication, all of that sort of good stuff. All right, monomial. Of course, think about the prefix mono. That's a single term. You have one term. So those are in the form. You'll have a coefficient. I'm just going to use a generic a for it. And then x to some sort of power. So that looks kind of crazy with all the variables. So just give you an example. Monomial. That is a single term. Product, notice my dramatic product sign there. Product is your operation. When you start adding more terms to it, adding or subtracting I should say, then it might be a binomial, trinomial, or of course just a general polynomial. So binomial, we have two of them. So I'm going to get fancy, and then my 5x squared, I'm going to add another term. Trinomial, of course, 3. I'm just going to add a term to this guy. Minus 1. Now I know it says add, of course, but remember subtracting is plus a negative, so really adding or subtracting on it. Polynomial, let's fill that in. Sum of monomials. And we're going to talk a lot about degrees coming up of the expressions. The degree, of course, is the highest exponent for power. We're going to say that. So just some basics. This probably looks familiar to you from Algebra 1. So of course, trinomials are 3 terms, binomials are 2 terms. Once you really get past trinomial 3 terms, they just go kind of a general, generic polynomial for everything from there. And then of course, what's going to be important when we start solving equations coming up here, of course, our degree, how many lovely answers we should have. So the degree, of course, is your highest exponent. So that's going to be especially important when we start solving. And generally, it's kind of one of those unwritten algebraic rules. You want to write your answers from the highest exponent to the lowest. So just some little nitpicky things for you. Okay, let's do it. So we're going to look at operations with polynomials today. So we're going to do adding, subtracting, and multiplying, basically, and get into a little bit of factoring. So adding, subtracting, combine like terms. We've all heard that phrase. So just to review, like terms, of course, same variables.
Where are you going to put this?
Just throw it on my desk for me. Raised to the same powers, or exponents, whatever you want to put. So you cannot add an x cubed to an x squared. They would both have to be cubes. You know like terms. All right, I'm going to work in order, also highest exponent to the lowest, so that leaves me some less work at the end. So I'm going to first start with the cubes. 1x cubed, 1x cubed. I'm going to add it to 2x cubed. Then I'm going to do the squares. So I've got negative 6x squared plus 5x squared. Negative 1x squared. And then I'm going to do the x terms. 2x plus negative 7x. And unfortunately, poor plus 4 is the only constant term. There's nothing to add to it. He just stays there. So again, just to kind of practice our vocabulary, 4 terms, we just call that a generic polynomial. Degree, of course, 3, the highest exponent. Some point 2, it's important also to identify lead coefficient. Lead coefficient, the number in front of the variable with the highest exponent, so 2. All right, let's live on the edge and subtract. Really, it's more of the same. X cubed minus x cubed. I like that, 0, I'm not gonna write anything. Let's do negative 6x squared. Careful on your signs here. Negative 6x squared minus 5x squared. Negative 6 minus 5. Got it. I'm going to do the x's next. 2x minus negative 7x. Minus a negative, really plus. 2 plus 7. And of course, last but not least, 4 plus 4. So I'm guessing we like adding and subtracting because there's no work really to do for it. Any questions adding, subtracting though? Figure I should do my due diligence and ask. Okay, multiplying. So here we go. Multiplying, of course, a lot of distributing or maybe foiling. Foiling, I have a love-hate with it. I just don't like it because it only works when you have a binomial and a binomial. Anything else, binomial, trinomial, you're just straight distributing. So it only works on a specific case. So I usually just kind of think of everything in terms of distributing. So here we go. Let's distribute. Now, binomial, binomial, you could FOIL it. I'm just going to straight distribute. So I'm going to do 2x times 3x, 2x times negative 5, 1 times 3x, and 1 times negative 5. All right, combine your like terms. Here we go. Negative 10 plus 3. Got it. And of course, just testing our vocabulary. 3 terms, so it's a trinomial, degree of 2, lead coefficient 6. Can't help myself, just got to review the vocab. Why not? All right, this one I could not do FOIL on even if I wanted to, because you have a binomial and a trinomial. We just have to suck it up and do all the distributing. 2x and x squared. So 2x cubed. 2x negative 5x. X and x goes to squared. 2x times 4. Okay, we're like half done. All right, I'm going to carry on here. Now I'm going to distribute 3 through. 3 and x squared. 3 and negative 5x. And 3 times 4. I'm running out of room. I'm going to sneak it down there at the bottom. All right, let's combine our like terms and, of course, put it in order. So only x cubed term, the 2x cubed, 10x squared, negative 10x squared, I should say, plus 3x squared, negative 7. Then I'm going to do my 8x minus 15x, and, of course, plus 12. So 4 terms, you would classify this just a generic polynomial, degree 3, your highest exponent, lead coefficient 2. Have I taught you anything new yet today? No, which is kind of nice, right? Okay, so last thing I have for you for product, before we get to some factoring. Now, do you have to memorize and use all of this? Well, let's kind of talk about that. The first ones, I mean, man, number 1, I love number 1. I don't want to say there's anything really quote-unquote memorizing because this plus and minus is why you don't have that middle term. So when I multiply something like number 1 together, I don't do the full FOIL. I just do the A and the B and negative B. You can just do a little shortcut on it. So that's kind of nice on that guy. These, it's up to you if you want to memorize the pattern or not, which those are the ones on the board. I like to use them because otherwise, let's say I'm super mean to you and I give you something like this. You would have to write out x plus 2 3 times. My arm is already starting to hurt. I probably could have just had the answer almost by this point. FOIL these together and then distribute that with x plus 2. So still going, still going. It's going to take me like 5 lines of work, or I can just use the shortcut, the pattern, and go straight to the answer with no work. Do I care how you do it? No, I don't care. But the bottom 2 will definitely save you some time. They will definitely be a time saver. And notice, I mean, the pattern's pretty similar. It's really just a matter of difference of signs, positives and negatives. Clearly, addition, it's all addition. Subtraction, notice the signs kind of alternate. Positive, negative. But otherwise, the pattern's the same. And we are going to do some of those with the pattern coming at me here in a minute. Okay, find the products using special products formula. Now, you can, it's going to pay me to write it a little bit. You can old school it and write it down twice and do your full FOIL on it. Totally can do that, okay? Nothing wrong with that. Or we can use our pattern here. We can use our shortcut, which is how I'm going to roll because it's going to be less work for me. So I'm going to square the first term, 2 times the product of the terms, and I'm going to square the last term. So I'm going to go right to the answer. So I'm going to square the first term, 2 times the product. Well, if you multiply these together, 3 and 5, 15x, I'm going to double it. and then you square the 5. Will you get the same thing if you FOIL that out and combine the like terms? Yes, okay, yes. Do I care how you do it? No, as long as you can get the correct final answer. Just trying to show you some shortcuts. Now, I do not want to write this down 3 times and have to do like 5 lines of distributing. Gross. So we're going to go to our patterns. So we've got the bottom one, subtraction. So first things first, we're going to cube the first expression. So think of this as your A and your B. Or, of course, it's on your notes, it's on the board up here. So first thing I'm going to do is cube this first expression. So I'm going to do x squared cubed. Now, I know you can do the square and the cube all in your head. I'm going to write it down. Okay, looking at your pattern. Minus 3, a squared b. Minus 3. So first term, a squared. So I'm going to square it. And then b is the 2. And I'll simplify and clean that all up in a minute. Plus 3ab squared. Plus 3ab squared. Again, we'll simplify that all in a minute. And last but not least, minus b cubed. Minus b cubed. So all I'm going to do is now simplify this. So power, we're going to multiply. Of course, x to the 4th, and I'm going to do 3 times 2 together. 3 times 2 is 6. 2 squared, 4. 4 times 3, 12. And what's 2 cubed? 8. Got it. So just a little bit of a shortcut. And again, I mean, you can do, 3 times. I hate this. And FOIL these together, FOIL it with the n, and have like 5 lines of work to get it done. You will get the same exact answer once you combine all the like terms after all the distributing. Just kind of a shortcut, just for the record. That's worst thing you have today. Okay, I like C. Man, I like C. C I can do with hardly any work because the plus and the minus. I don't have to do the full FOIL on it. The plus and minus is going to make the middle terms cancel. So I'm going to skip them. I'm going to do 2x and 2x. The middle terms are going to skip to cancel out. And now I'm going to write them down. I'm just going to do the last ones. Square root of y, square root of y. Got it. And again, you can do the full FOILing, but you're going to see that the middle terms cancel. Now I'm going to show you a trick on D. Because at first I'm like, oh, Lord, a trinomial times a trinomial, I'm going to have 9 terms. It sounds like a lot of work. Or catch it. D is kind of like C, because I see this minus plus situation, and you do have these being the same thing. So I'm going to kind of multiply it the same way, but I'm going to try to work smarter, not harder, because I don't want to do 9 full terms. That seems yucky. So I'm going to do this x plus y's together first. Yes, I know I'm going to have to distribute and deal with that squared situation, which I'll do in a minute. So I did the x plus y's together. There's 2 of them, so squared. I'm going to skip the middles because they would cancel, -1 and 1. So I'm kind of doing it the exact same way because I catch that minus plus some stuff will cancel. Well, now I'm going to use my shortcut. You could write it twice and FOIL it. I'm going to use the shortcut. Square the first term. If you multiply this, you have x, y. You're going to have 2 of them. And then square the y. I still, of course, have -1 at the back. No like terms. Circle it up. You will get the exact same thing if you write out all 9 terms, do the full distributing, combine all of the like terms. Just trying to show you some shortcuts to make your life a little easier. Do you have to use the shortcuts? No, but they will save you some time. Yes, sir?
Wouldn't you want the y squared to be before the 2xy?
You could, but since you have different variables, the order is not as picky for the standard form. Yeah. So I'll take it any way I can get it. All right, let's get into factoring. I feel like I'm really, besides those shortcuts, not really teaching you a whole lot of new stuff here today. So factoring, of course, oh gosh, I want to say there's like 6 different types of factoring. Don't worry, we're not doing all 6 today. We're going to talk about greatest common factor, trinomials, lead coefficient 1, and then we're going to get into grouping. Now, factoring, cannot stress to you the importance of factoring, keeps coming up over and over to solve some of these problems. Reversive distributing. So my answers should look like they need to be distributed out when we're done. So here we go. Greatest common factor. It's the first type of factoring they ever teach you back in your Algebra 1 days. So I'm going to look at what's in common in both terms. 3 and 6, well, they both have a 3 in them. X squared x, they each have an x in common. So that acts like your distributor. I just got to figure out what would you have to distribute it through to get the original problem back. I'm going to need another x. 3 times 2 is 6. Like it. Hardly any work today. Winning. Okay, middle one. 8, 6, 2. Well, I'm going to do the numbers first. 8, 6, 2, they at least need to have a 2 in them. 4 x's, 3x, 1x. Only a single x in common. Y squared, y cubed, y to the 4th. Well, they each at least have a minimum of 2 y's. So that's going to act as your distributor. 2 times 4 is 8. I took one of the x's out, so I'm going to need 3 more to get to the 4th. I took the y squared already, so I don't need anything else. 2 times 3 is 6. Took 1x, I'm going to need 2 more to get to cubed. I took 2 of the y, so I need just 1 more to get cubed. And last but not least, I'm running into C here. I took the 2, I took the x, I took 2 y's, 2 left. Got it. I'm guessing we're pros at this. All right, C, maybe one kind of tricky one. I can't even say that with a straight face. This really isn't that tricky. What's in common in C? What do you see multiples of? What expression?
X minus 3.
Yeah, it seems weird, but that's our greatest common factor. I'm going to factor x minus 3 out. So to get the first term, I need the 2x plus 4, of course. And to get my last term, we need the 5. Well, let's go ahead, combo, put together the 4 minus 5. Looks like a distributing problem to me. We've got it factored. So kind of maybe a little different or a twist on a greatest common factor. You're probably used to things like A and B, pretty straightforward. But both terms did have x minus 3 in them. So that does act like a greatest common factor for you. You can pull that out. It's as wild as that gets. All right, here you just got to know your times tables. Trinomials, 3 terms. A lead coefficient 1. So these are all 1x squared in the beginning. That's what they're talking about. So here's where we're going to do our times tables. We're going to multiply to the constant term, the last number, and add up to the middle, the linear term. All right, knowing what multiplies to 12 and adds to 7. 4 and 3, so x plus 4, x plus 3. And of course, you could have those switched. You could do x plus 3 first. You can always check your answer by foiling it out, too. All right, multiply to 10, add to negative 11. Negative and negative 1, yeah. Multiply to negative 24, add to negative 5. What do you got? Yeah, x minus 8, x plus 3. Perfect. I'm guessing we are masters at these, and I've taught you nothing on this part. Nothing tricky here. Any questions on that? Okay. Moving on. Grouping. So probably you've done grouping. Grouping comes up. It's probably not as common of all the factoring. You probably see greatest common factor a lot, and then those trinomials. Grouping, we are going to see it, cover it. It does pop up here. So 4 terms, of course. 1, 2, 3, 4, 4 terms. So what we're going to do is we're going to split it in the middle, and you basically make 2 groups of 2. So many 2's. Basically, you're going to factor GCF out of the front half. So I'm just going to look at x cubed, x squared. I could take x squared out of that. Need another x. And just a 1 to hold the place. Then off just the last 2 terms, do the back in purple. Well, they each have a 4 in common, so 4 is my GCF. Need an x. Now, your parentheses should match. If your parentheses, if the x plus 1's do not match, something bad has happened and you need to, of course, adjust that. So just like that greatest common factor problem we did, x plus 1 they have in common. And then, of course, I need an x squared to get the first term and a 4 for the last term. And, of course, if you FOIL that all together, you will get the original problem back. All right, let's do this guy. Split it in the middle. So off the front two terms, I'm going to start with those. I can take an x squared out. I'm going to need another x and a minus 2. Let's do the back two terms. Now, obviously 9 goes into both of them. Here's a question for you. Are you going to take 9 or negative 9? Ooh, a mixed bag on it. Well, let's test it. I heard some say 9. Don't write this. Let's test it. I heard some say 9. Why am I making a face? They don't match. The signs are switched. So I said, don't write that. Don't write that. Okay. So I'm gonna erase that. Okay, and let's go negative 9 now. Okay, all right. So conscientious of the signs as always. You'll hear me say that like a million times, like every math teacher. So final answer, our GCF, that x minus 2. And then we're going to need x squared, and of course the minus 9. Now, for fun, I'll let you leave it at this point for today because I'm saving perfect squares, here's a hint, for tomorrow. Do you remember how to factor this? X plus 3, x minus 3, which we're going to do some of that tomorrow. You can leave it like this for today. I wouldn't be upset about that. But you know, the love of math, that is difference of perfect squares and can be factored down again. I'm going to circle both. I'll take either for today. But tomorrow, once I show you, of course, the perfect squares, I would expect you to factor it all the way down to the very last step here, okay? But for today, I'll take either. So any questions on grouping? Man, too easy today. Okay,